In the previous video, we left off on this example where a binomial was a common factor to a polynomial. We are going to use this method in the next example, which is factoring by grouping. When you're factoring by grouping, you will have a polynomial with 4 terms, and none of the terms will share any common factors, so there won't be a greatest common factor for the polynomial right off the bat. In order to factor this type of polynomial, you will need to use the method called factoring by grouping. Step 1 of factoring by grouping is to put brackets around the first 2 terms to make a group, and to put a set of brackets around the last 2 terms to make a second group. Then you look for a greatest common factor for each group separately, and notice that the greatest common factors for each group may be different. Once you know the greatest common factor for each group, you will divide each group by its greatest common factor, and you will do this separately for each group. You will notice that the leftovers that you have in the brackets from each group should be the same. Then, in step 4, you will use the binomial that's in the brackets as the greatest common factor to finish factoring the expression. The greatest common factor will become one of the factors, which the binomial, and all of the leftovers after you divide out the binomial greatest common factor is the second factor of the expression. So let's look at a couple of examples. In example 3, we have a 4-term polynomial that we need to factor out. So let's list out all of the factors for each term. For example, the first term is y squared, has factors of y and y. So I've gone ahead and listed out all the factors of all 4 terms, and now we need to compare to see if they have any in common. We notice that the first 3 terms have y's, but the 4th term doesn't, and the second and 4th term have x's, but the first and 3rd don't. The second, 3rd, and 4th terms have 2's, but the first one doesn't. So there does not appear to be anything that all 4 terms share in common. So this is a sign when we need to factor by grouping. So I've rewritten my polynomial here, and in step 1 we're going to draw brackets around a set of brackets around the first 2 terms to make our first group, and we draw a set of brackets around our last 2 terms to make our second group. Now we look for a greatest common factor for each term or each group separately. So let's look at our first group first, and you can totally ignore the second group. We have a y squared and an 8xy. The most that these 2 terms can be divided by is a y. So they have a greatest common factor of y. So we're going to go below and write our greatest common factor first, and then in brackets following that greatest common factor, the leftovers after we divided by y. Y squared divided by y is y, and 8xy divided by y is 8x. Now we can go ignore the first group and just look at the second group. The most that these 2 terms can be divided by is 2. So we're going to divide each term by 2, their greatest common factor. Where we write that is just right after the stuff from the first group. So we write plus 2 as our greatest common factor, and then in brackets following that, the leftovers after dividing. So 2y divided by 2 is just y, and 16x divided by 2 is 8x plus 8x. You'll notice that I wrote a plus sign in front of my greatest common factor of 2 because I did divide by a positive 2 here, and we need a plus sign because this is now all one polynomial again with 2 terms. We have our first term here and our second term here. And we'll notice that we're going to factor it again, but our greatest common factor is now the binomial, just like we did in the previous examples. So the binomial y plus 8x is now our greatest common factor of the entire polynomial. So we're going to divide each term by that greatest common factor. We write our greatest common factor out front as one of the factors, and then everything left over goes in the second factor after we divide. So y plus 8x divided by itself is just 1, and we're left with y. And y plus 8x divided by itself is 1, and we're left with plus 2. So our expression in factored form is equal to y plus 8x times y plus 2. And if you want to check your answer, you can multiply out using FOIL or the distributive property, and you will discover that you will get back to the same polynomial you started with. This method of factoring by grouping is very important when you get to lessons 5.3 and 5.4 when you're factoring trinomials. You will be using factoring by grouping. Lastly, let's look at the word problem example where you can use the greatest common factor to solve a problem. Noah has 18 toonies, 30 loonies, and 48 quarters. He wants to group his money so that each group has the same number of each coin and there are no coins left over. What is the maximum number of groups he can make? How many of each coin will be in each group? And how much money will each group be worth? To find the maximum number of groups, we can identify the greatest common factor of 18, 30, and 48, the numbers of each type of coin. The factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And lastly, the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 40. So if we look for the factor that is the greatest that they share in common, we'll find that they all have a 6 as the largest factor. So 6 is the GCF, and that means that the maximum number of groups that they can have is 6. Next, for part B, if we want to know how many of each coin will be in each group, we want to divide each number of coins by the greatest common factor. So if there's 18 toonies, this is the toonies, and we're going to have 6 groups, that means that 18 divided by 6 is 3. There will be 3 toonies in each group. If we look at the loonies, L, we had 30 loonies divided into 6 groups, gives us 5 loonies for each group. And lastly, for the quarters, we had a total of 48 quarters divided into 6 equal groups, gives us 8 quarters per group. Then we can go ahead and find how much each coin has in value and then find the total value for each group. So toonies, of course, are $2. So if they're each $2 and there's 3 in each group, $2 times 3 is $6 total for the toonies. Loonies are worth $1, and there were 5 of them in each group, so that's $5 worth of loonies. Quarters, now we want to talk about quarters in terms of dollars, so quarters are $0.25, and there was 8 of them in each group, so that gives us a total of $2 per group. The total value of the coins is, if we add up all of the coins' values, we have $6 plus $5 plus $2, which will give us a total of $13 in each group. Alright, so now you are ready to try the practice questions from lesson 5.2 on common factors, and make sure you practice these a lot because being able to find the common factors and factoring polynomials is a key skill in mathematics.